Hello guys, let's get right into it. Today we're going to talk about the Rectified Linear Unit, ReLU, commonly used in neural network models. So what is it? It is an activation function that basically converts negative inputs to zero while positive inputs remain same. An activation function is a simple function that transforms its inputs into outputs that have a certain range. In this case, ReLU converts it to a range of 0 to infinity. So what does it do? ReLU helps to prevent exponential growth in the computation required to operate the neural network. This causes a problem called exploding gradient problem if ReLU is not used. This is whereby the gradients, which updates their weights, are large. This makes their multiplication way large over time, whereby it takes longer processing time and requires more processing power, making it more difficult to train and test a model. So there are certain extra details on ReLU. First of all, it is a monotonic function. A monotonic function is a function that is either entirely non-increasing or non-decreasing. Well, it also introduces nonlinearity to a neural network model. This makes it commonly used hidden layer in neural network models. It makes it easy for the model to generalize or adapt to the variety of data and to differentiate between the outputs. Its formula is as simple as fx equals to max 0 x, and there is the graph, as we shall see in the codings. So open the new Colab tab. I've named it ReLU. The first thing I'm going to do is to import torch, because I'm going to use PyTorch. Import torch, then I'll also import pyplot. From that, I'm going to use torch.relu to return evenly spaced values within a given interval, as you shall see, to create the small dataset that will be used to depict ReLU. Let's create a start. So this is what a range normally takes in the start, the end, and its step. And we're going to use the data type of float. It's called data, and see what it has. With this data, let us create our first graph using torch.relu and the matplotlib.pyplot. With this, you can see that anything that is in the negative side has turned to 0, and the remaining values that were above 0 have maintained their values. We could also define our own ReLU function so that you can see how the max works. Define ReLU. We want it to get only tensors, so we're going to use torch.tensor. And also we want it to return a torch.tensor. So we'll return torch.maximal torch.tensor 0 and x. So that we could print the data, create new data 1, ReLU data, so you can see anything that was in the negative has turned to zeros, and then our 0, and then the 1, 2, 3, 4. With that, we can plot data and new data 1 to see the differences. plt.plot data, it's a linear line. plt.plot, pass it to our function, and yes, creates the same shape. This is what happens when you add an n.relu in your neural network model in the backend. With that, I hope that you have understood what ReLU is. Thank you very much.